Good afternoon, everybody, and welcome to this afternoon's intermediate Python workshop for computational economics, data science, and econometrics. It's my pleasure to introduce today's workshop facilitator, John Stachurski, who is a professor at the Australian National University and a co-founder of Quanticon. So I'll hand it over to you, John. And for students, if you have any questions throughout the session, please add them to the Q&A chat. And you'll also have an opportunity to ask questions via voice throughout the workshop, and we'll be able to unmute you for you to ask those questions. So thank you, John, all yours.
Great. Okay, so thanks, Caitlin, for the introduction. Hello, everybody. As Caitlin said, my name is John Stachurski. I'm a professor of economics. I've been at ANU for about 10 years or so. Before that, I was at Kyoto University and various places before that. And my field is economics and finance, and I'm particularly interested in dynamic stochastic systems. I'm actually going to jump ahead and share my screen so you guys got something to look at. And we don't need to share that screen. Let's have a look at this one. Yeah, so that's me there, John Stachurski, in one of the extremely rare occasions where I was caught wearing a suit. And I'll just click on that and take you through to my website. And the reason I'm doing this is that if you scroll down a little bit, you can find contact details for me. So as we go through the workshop, I do encourage you to ask questions. But if you get to the end of the workshop and you didn't get a chance to ask, or you are seeing this later in a recording and you have some burning Python questions or research-related questions that you'd like to ask, then please do feel free to get in touch, and I'll do my best to answer them. All right, so like I said, I work in dynamic systems. I was previously very interested in theory, but even then I used a lot of Python and computing to try to simulate systems and explore systems. So even before I did something mathematical, like trying to do a proof, I was running code to get a feeling for what the system looked like and the shapes of different objects and so on and so forth. And now I'm veering towards more practical things, so things related to forecasting and estimation, and the role of computing in Python is even more obvious there. So I've been a Python user for, I guess, about 15 years now. And I have tried a lot of different languages, and I had tried a lot by the time I tried Python, and it just immediately clicked for me. So, you know, you're going to find that with different programming languages, they just work for different people. Some people have, you know, think about things in certain ways that makes maybe R more attractive, or something more foundational like C. But for me, Python really clicked, and I'll try and explain why that was the case as we go along. And it's clear, given the rise in the popularity of Python, that the same is true for a lot of other people. So what I'm going to try and do today is I'll give you a very high-level view of Python for scientific computing. And I think it's a little bit much to try to teach you guys to code in Python in an hour. That would be tough going. But what we'll try to do instead is get, like I said, a high-level view, and also do a little bit of hands-on stuff. So we'll look at barriers to entry, like how you can get started, how you should get started, and writing your first few lines of code in Python. Now, I anticipate that some people that are listening in already have Python experience, and there may be parts of this that are tedious for you, but I'm kind of aiming at a baseline where people are computer literate and bright and comfortable with computers, and maybe have some experience with things like Stata and Excel and Matlab, but don't know so much about Python. That's really the baseline that I'm looking for. So I'll tell you a little bit more advanced stuff as well, but that's kind of the level that I'm going to aim this workshop at. As Caitlin said at the very start, you're welcome to ask questions, and you know, the benefit of something like this is that we can be interactive, and you can you can ask questions through the, whether it's through chat or the Q&A, or getting yourself unmuted. And please, by all means, if you have questions, do ask them. All right, so let's see. So what you're looking at here, so one of the things I want to do, apart from just getting you up and running, is I want to give you some resources that you can use to learn Python and working with Python in a scientific environment. And I'm going to point you to some code libraries, and I'm going to point you to some lectures, and we'll work through some of those lectures. And the lectures are partly written by me and partly written by other people, and they're based on, or they are hosted at an organization called Quanticon, which I'm now looking at. So I'm at Quanticon/team, quanticon.org/team. And that shows you the committee members for the steering committee and the co-founders. So the other co-founder of Quanticon is the guy on the top left. His name is Tom Sargen. I'm actually really privileged to be working with him. He's he's a Nobel laureate, but some Nobel laureates in economics are pretty wacky, but he's not one of the wacky ones. He's like a genuine superstar who, his research has had an enormous amount of impact when I think about it. He was really part of what was then a new wave in the 70s and 80s, a new way of thinking about economics. And actually, I think I'm not sure if he'd be entirely pleased with all of the impact that he and that group of people had. It paved the way for a kind of a political revolution as well, which has had enormous impact on the whole world. So your research can have an amazing amount of impact if you're smart and you go about things the right way. And so Tom, he's a very smart guy, but he's also very curious and constantly wanting to learn new things. He's now in his late 70s, I guess, but he's always learning and always keen to learn. And we got to know each other actually because of Python. So once I found Python, I was really enthusiastic about it. And that's partly because I like the language, but it's also partly because it's open source. And I'm a believer in open source. I think that open source leads to open science, and open science leads to reproducibility, and reproducibility as well as kind of like democratic ways of thinking about scientific research. And I think all of those things are very healthy. So I immediately started encouraging people to use Python, and I put some lectures up on the internet that were teaching people, economists who weren't using Python at the time, how to get started with Python. And at first I had like a lot of criticism and a lot of pushback and not a lot of enthusiasm. And I thought, if I could convert someone who's like right at the center of macroeconomics, of economic modeling, that would really make a big difference. And lo and behold, I get an email from Tom Sargen saying, "Hey, I like your Python lectures that you've put online, and can you tell me a bit more about them?" And of course, I was eager to do that. And then one thing led to another, and we were exchanging emails about doing computing in economics using Python, and then meeting up and working together, and then founding organizations like this one, which I said before. As I said before, it's dedicated to hosting and organizing development of open source code for economics and finance, econometrics, statistics more broadly. And the languages that we handle are, at this point, Python and Julia. And the one that I have consistently been the most enthusiastic about in terms of just sheer productivity and enjoyment working with is Python. So that's hopefully a little bit of motivation for you guys. And on top of the motivation, so going back to quanticon.org, there are some lectures that I'm going to point you guys to. If you go down the page a little bit, we see that there's lectures here. And I'm going to be working with you to understand the first couple of these lectures. And then there's an enormous amount. It's kind of going crazy. I don't know how it happened that we have this many lectures. But so all of these are different lecture series. And we're going to be taking a look at the first of these lecture series, which is called Python Programming for Economics and Finance. And for those people who want to, I'm going to give you the means of following along with the code that I'm writing. So that will get you started with these lectures. And there's, like I said, many more to explore after we go through the first couple of them. All right, so that's essentially what we're going to be doing. Please don't hesitate to shout out if there's problems with audio, or like I said, you have other questions, or if the font size is too small. Otherwise, I'm just going to keep going. All right, so as I said, I'm going to do some hands-on stuff with you guys where I'll show you how to do a little bit of coding in Python, and you can work with me or alongside me as I write that code. But just before I jump into the hands-on stuff, I'm going to take a little look at a research project that I've got on the go at the moment, which is with a few friends of mine and colleagues and research assistants. And the problem is one of forecasting consumption growth. And we're talking here about aggregate consumption growth. It's a component of GDP. It's measured in the national accounts. And it's one of these things that people are eager to forecast, as they are things like the unemployment rate or the inflation rate or GDP. All of these things are of interest, and we just happen to be looking at consumption at the moment, although I suspect that the tools that we're creating are going to be very valuable for forecasting some of those other aggregate variables as well. So what you're looking at here is a GitHub repository, and if you're technically minded and research orientated, which I guess all of the people listening to this workshop are, then you definitely want to familiarize yourself with Git and GitHub if you haven't done so yet. So for the people who are not familiar with Git and GitHub, what it is it's like a version control system, which means that we have a way of tracking changes to our files, our code, the code that we've written. And then on top of that, we have ways of collaborating with each other to build out the code base and add functionality and do the things that we want to do. And with apologies to those people who are already familiar with Git and GitHub, let me just show you a little bit about how we organize this research project, because I figure it will be of interest to people who aren't so familiar with it. But the basic idea with GitHub repository is we've got code, which I'll show you in just a second. The code is still there, and we've got instructions for reading that code. And we've got a set of issues in the issue tracker. So there's JStack, that's me, and I'm making some suggestions about things that we should be adding to the README file. And here I'm saying that we should be doing principal components regression. And I've collected some material there that's going to help us do that. And then we've also got pull requests. So pull requests are ways to add new data to the repository, to the code base, or new code, new functionality. In this case, one of our collaborators has made a proposal to change some files. And we can see here the kind of changes that he's proposing, and we can review them, and then we can go back to the conversation and we can chat about it and say what we want to do and what we don't want to do, and ask him to make changes or suggest some ourselves. And once we're happy, we'll hit that green merge button and bring it into the code base. So, with your very first Python programming projects, if that's the stage you're at, you're not going to be worried about using GitHub. But as soon as you start doing something bigger, and as soon as you start collaborating with a team, you're going to find that Git is going to be essential to what you do. And for serious teams that you end up working with, so if you end up working with a professor during your master's or your PhD or late in your undergraduate, and you're part of a team that's doing some code, so all of the good ones who know what they're doing will already be using GitHub, and they will expect you to be fluent with it, Git and GitHub. And the ones who aren't using it, you need to take over the research team and tell them what they should be doing. So apart from investing some time in learning Python, please invest as much time as you can in becoming conversant with Git and GitHub. I'm not a guru myself. I've been using it a long time. I have other people. I have smart RAs that I rely on who are really good at GitHub, but it's a great skill. All right, so that's how we collaborate, and now let's have a look at some of the code that we're writing. This is a piece of Python code, and since we're just starting out with Python here, we don't expect to understand everything that's going on. But what it is this guy is doing some forecasting with deep learning. So, unless you've been living under a rock, you've heard about all of the deep learning projects that are going on at places like Google and Facebook. And these neural networks are becoming amazingly good at various kinds of tasks. And this guy, who's one of the guys that I work with, is trying to apply those same methods to forecasting consumption growth. And he's doing that by importing a library called PyTorch. And if you look at all these import statements, I'm saying import this, import that, or he's saying. And one of the things he's saying is import PyTorch. And what PyTorch is, for those people who don't know it, is this is a typical Python library. It's actually a very famous Python library, a code library, which was developed by Facebook. And in one of the few benign things that Facebook has ever done, has been open sourced and made available to the wider community. And it has a bunch of super high quality routines for deep learning and working with neural networks. So he's importing that functionality. Like I said, it's free, it's open source, anyone can use it. There's a big community of users, and he's trying to forecast consumption growth. Now, I'm not going to go through all of that, it's pretty complicated, but I'll just show you one more notebook. So this is one that I've written, and it's another approach to forecasting consumption growth. And again, this is, we're leaping right into the middle here, rather than starting at the start, but I just want to show you a little bit of Python code in action. And you can see that both of these programs, it's actually a Jupyter notebook, and I'll say what that is in just a second, but we're starting off by importing a bunch of stuff. And he's importing PyTorch and some other things, and I'm importing NumPy, something called NumPy, and something called Pandas, and Matlab and scikit-learn. So these are different libraries. And the scikit-learn one, it's like another machine learning library. It's this one here. That's another of the biggest, maybe these are the two biggest machine learning libraries for Python at the moment, scikit-learn and PyTorch. There's other ones as well. I'm not sure which is the biggest. These would be among the big two. Anyway, I'm using techniques from scikit-learn. He's using techniques from PyTorch. But part of the reason that I wanted to bring this stuff up is that when we think about learning Python for scientific programming, the core Python language itself is really, really small. And it's deliberately kept small because that makes it much easier to maintain and optimize. If you have a big language with lots of stuff going on, it's harder to make it really good. So Python's philosophy has always been to keep the language small. And anytime we want to do anything even vaguely interesting, we do it through external libraries, libraries that we import. So whether you're using Python for something like web development, or you're using it for game development, or you're using it for something else, you're going to find that you're importing, you really can't do anything unless you import libraries. So, you've got two tasks in front of you, and task number one is learning Python, the core language, and then task number two is learning 3 or 4 libraries that you think you're going to be using. And they're kind of separate things. And, I could teach you about scikit-learn or PyTorch, but that's really kind of niche. So really the main message I want to get across is that you should invest time in learning the core Python programming language before you leap into the libraries. Don't go straight to PyTorch. Learn Python before you learn PyTorch, and you'll find that you have a much better foundation and you have a better understanding of why things are being done the way that they are being done, and you'll generally be much less frustrated. So that's one message. The other message is that when we do scientific computing in Python, there are some libraries that are common to everyone, and pretty much everyone's going to be using them. And the first one up the top there is something called numpy. And numpy is a library that provides arrays, numerical arrays in n dimensions. These days, they're sometimes called tensors. And it's just really well engineered, super stable, super optimized. And every Python program that I write starts with import numpy as np. I'll show you a couple of programs in a second, and they all start like that. So that's the other message, is that there are some core libraries. Learn core Python, and then there's a couple of libraries for scientific computing that you really want to master, that you actually do want to master, like regardless of what niche you're interested in. And there would probably be numpy. And then if you're interested in data, the next one's called pandas, and that's for manipulating data. And if you do anything data related, then you want to be using pandas. And again, pandas is like massively popular, and it's, to a degree, it's responsible for the rise of Python in the fields of data science and machine learning and artificial intelligence, because it's such a nice library for manipulating data and so fast and well optimized. And then the third one there is Matlab, which is probably the standard library for generating figures and graphics. And I'll show you a bit more about that one in a second. All right, so you do want to invest some time, regardless of your interests. Probably those 3 libraries: NumPy, Pandas, and Matlab. And I'll come back to them and show you a bit more about them. All right, so that's kind of background, and I think we're now ready to jump in and start doing some stuff. Are there any questions at this point? All right, so yeah.
We had one question in the chat just from earlier, and that is, do you think languages like Julia will replace Python over the next 5 years?
Yeah, it's a really interesting question. So Julia is I mean, maybe you know a fair bit about Julia already, but so the big thing about Julia is it has the just-in-time compiler, and the just-in-time compiler is really clever and blazingly fast. And so when Julia first appeared on the scene, I was super excited by it. And I got to know the developers when I was in New York, and I talked to them a fair bit. And, I guess it took a long time to become stable, and I got kind of frustrated in the middle there. And I think it's a lot more stable now than it was. But in the meantime, what's happened is that core technology, the just-in-time compiler, there's actually a Python library, which I'll show you guys, a bit later if I remember, and feel free to jog my memory, called Number, which uses a just-in-time compiler to generate. So what these just-in-time compilers do is they generate fast code. They generate highly optimized machine code, which allows us to execute things blazingly fast. And there's quite a few different languages that are starting to use them, but there's only a few languages that have them working really, really well for scientific computing. And probably those two are Julia, because they're really the guys who kicked it all off. And then the other one is Python. And so through the Number library, you have access to a JIT compiler, a just-in-time compiler, and that JIT compiler is actually built on exactly the same architecture that the Julia one's built on, and it's exactly as fast. So the fact that, and really, you know, that they copied what Julia did, which is harsh maybe, but for me as a user, I'm delighted by the competition. And I'm delighted that Python now has this technology as well, and I use it all the time. So for those kind of reasons, right? And then there's this debate, like, you know, in Julia, everything is JIT compiled, and in Python, it's part interpreted, part JIT compiled, which sounds like a nasty hack, but it might actually be the sweet spot because interpreted languages are really flexible and they have various advantages, and you don't actually need most of your code to be fast. You only need small parts of it to be fast. And so JIT compiling small pieces of code as required, which is exactly what PyTorch does as well. Scikit-learn, I know less about the internals, but I think they use Number 2, is proving to be maybe even the optimal strategy at this point in time. So that's a really long answer, but the short answer is I don't think so. My best guess is no. I think that Python is going to be top dog in artificial intelligence and data science for the next 5 years, and then, you know, who knows after that? I have no clue. Does that answer people's questions? Are there any more questions? All right. Okay, so having gone through all that, let's actually do some coding. And I invite people to follow along with me as I do this. So to run code, well, we can do it two different ways. One is that we can do it remotely. That is, the code's going to be running on someone else's machine. Or we can do it locally. That means the code's running on our machine. Now, if you want to do it locally, then you need to install software. And you may or may not be willing to do that or able to do that at this point in time. So let me give you a remote option for playing around with Python in a data science environment. That's remote and doesn't require any software installation. And this one here, so this is called DeepNote. So it's deepnote.com. I don't know if I can bring that up larger. DeepNote. Yeah, it probably looks different to you guys because I'm logged in already, but so the URL is deepnote.com. Now, they provide a free tier where we can interact with Python and use the scientific libraries in a convenient way. And what you need to do in return is sign up. And to sign up, you can use something like a Google account or a GitHub account if you have one. So I am not by any means, you know, advertising this company. I really don't know much about them. These kind of services come and go, and I personally tend not to use them very much, just for various reasons, which are idiosyncratic to me and my team. But for now, it's actually pretty convenient if you're willing to sign up. So what I'm doing is I've got a starter project, and I'm just going to click on that, and it's probably going to give me a code prompt. All right, so let me move this down here somewhere. All right, so now what I'm going to do is I'm going to grab a code block like this, and I'm going to say 1 + 1, and I'm going to run that. And to run it, you can press run, or you can hold down the shift key and press enter, and it's executed this piece of code. And so what's happening there is that that little piece of Python code, 1 + 1, is sent off to a server that has a Python kernel listening on a particular pod, and that code is executed on the remote server, and then it's sent back and displayed in my browser. Now, for doing little things like adding up 1 + 1, that's probably more trouble than it's worth, and there's a little bit of a lag and so on. I mean, this is a free tier. I'm paying nothing for this, so I don't expect too much. But for something like this, I would, if I'm just mucking around with a piece of code, I'd probably do it locally, and I do most of my computing locally. But this kind of cloud computing that they're offering is obviously the way things are going, and it can be super convenient because when I'm working on a particular project, like I'm working on a different project related to asset pricing, it's nothing to do with forecasting, and that project is using GPUs, graphics processing units, if you know what those are, and to do high performance computing. And it's actually not something I know a heap about. And so I'm working with a guy in San Francisco who did work at NVIDIA, which is the major maker of GPUs, the biggest maker of GPUs, and another guy who's based in New York. And they're helping me with the nitty-gritty of the GPUs. But what it means for this cloud computing is that we can just go to Amazon's web service system, AWS, and we can log in there and create any machine that we feel like playing with on a given day. So we might need a lot of RAM, or we might need fancy GPUs, or we might need a big CPU. And with a few clicks, you can set the whole thing up. And then you can interact with it remotely in the way that I'm doing here. That kind of stuff is not too hard to do. So yeah, so that's kind of the way things are going. But let's have a look at a local option now for running code, and that's mainly what I'm going to work with. All right, so if we want to do things locally, we need to install software. And the software that we want to install, what's the best way to do this? Yeah, so I'm going to type in here Anaconda Python. So that's Anaconda as in the snake, and then Python as in the other snake. And that takes me to this web page here. And so Anaconda is not just Python, but also a bunch of scientific libraries for working with Python. And you can definitely avoid Anaconda by downloading Python. Just go to python.org and get Python, and then individually downloading particular libraries for scientific computing. If you want to go down that route, that's certainly fine. But what Anaconda gives you on top of that is it gives you a package manager, essentially, that is going to keep all of these libraries up to date, or allow you to do so, and it's going to make sure they play well together. So if you've got 20 different libraries, and this particular library, PyTorch needs scikit-learn version 0.3, and scikit-learn needs numpy version 5.2, and that one needs this, and you get these crazy chains of dependencies, and doing it yourself is a horrible mess. And so that's where Anaconda comes in. So if you're going to do scientific work with Python, there used to be competitors to Anaconda, but they've just been crushed, and not in a bad way. Not crushed because Anaconda is evil, but crushed because Anaconda is good. It's just they just did such a great job that everyone uses it. All right, so then you can go through the process of downloading. Just follow the instructions to download and install it, and it'll be available for use on your local machine. So what I'm going to do now is I'm going to jump over to working on my local machine and show you a little bit more Python code. Is there any more questions at this point in time?
Members of the audience, feel free to raise your hand and we can unmute you and allow you to ask your question if you prefer not to type it into the chat. Otherwise, please use the Q&A.
All right, well, just feel free to shout out and interrupt me. That's fine. Okay, so let's imagine that you've hit download and hopefully you have a fast connection, or you've already done this and you have it installed. And now we're going to fire up one of the libraries that's provided by Anaconda, or one of the applications, I should say. And that's called Jupyter Notebook. So I'm going to type that in. So let's see. So yeah, okay. So I should say how you start. I'm going to start an application called Jupyter Notebook, and just so you know what I'm talking about, I'll put it up on the screen. So Jupyter. Well, I'm going to show you what Jupyter Notebooks are, but it's gone from kind of niche to now industry standard across, not just places like Facebook and Google and so on, and the more technically advanced parts of academia, but also, places like Wall Street and private enterprise. They're all using Jupyter to interact with Python. So this application that I'm going to show you, Jupyter Notebook, is a way of interacting with Python in the sense of typing Python commands and having them execute and seeing the results. And it's only one of those ways. There's many different ways that you can do this, but this one's particularly good for data science and scientific work with Python because it's highly interactive. And the standard version of it, so I'm typing here Jupyter-Notebook. I do everything in the terminal, and people are going to be different in the way that they do their computing. And if you tend to do things more through the menu, right? So bring up, I'm on a Linux machine, it's going to be different for you, right? But if you search for, let's say, Jupyter, Jupyter, so the PY is for Python, JU is for Julia, which we talked about before. PY is for Python, and Turbo, well, it's kind of a play on R, the other very popular open source language for scientific computing. Julia, Python, and R. So these Jupyter Notebooks are language agnostic. You can use a lot of different languages in this environment. So either type it in a terminal, Jupyter-Notebook, or search for Jupyter, or search for Anaconda, and hopefully you're going to find a way to start the Jupyter Notebook application. And when you do that, it's going to start a browser. And in the browser, I'll see what's called the Jupyter dashboard, which looks something like that. And it'll look different for different people. This is showing me files and folders that are in my present working directory. But I'm going to ignore these, and I'm going to go up to the top right here, and I'm going to click on New. And that's going to give me a new Jupyter Notebook to work with. And now I can do exactly what I was doing before. So 1 + 1 is 2, x equals 1, y equals 2, x plus y gives me 3, and so on. Okay, so now we're interacting with Python via Jupyter. And as I said before, that's not the only way that we can interact with Python, but it is super convenient for doing scientific interactive work, and it's very convenient for documenting your research. And it's becoming, actually, like if we look at the lectures that I was showing you before, so I'm just going to jump over to the lectures on Quanticon. So we got all these lectures here. and I was just showing you some of them. And these are actually written to mimic Jupyter notebooks, and they use Jupyter under the hood. And so we'll be working our way through a couple of these lectures now. But I'm involved in a larger project called Jupyter Book, which is writing textbooks and entire websites using Jupyter. And that's essentially what we've done through Quanticon in order to produce all of these lectures. So you can kind of get a sense from looking at the website that, you know, you have a nice looking website, and you can combine code, and you can combine pictures, and you can generate outputs and so on in maths. And we can do that right now. If you haven't done this kind of thing before, we can do this here. And just to give you an example of that, so regardless of whether you end up using Python or not, like, you know, there was a question about Julia before, and then some people are interested in R. Regardless of which language you end up using, you can use Jupyter Notebooks to organize and document and run your code. And if you're not familiar with them, so let me just show you a couple of things about them. This is a code cell, so I can execute code here. But I can change it to a markdown cell. And now I can say, so markdown is like a way of writing rich text. So I can say, this is a title, something like that, and subtitle, title. And I can execute this, and then I can add in some dot points, dot point, another dot point, right? And here's, sorry, this is a tiny little keyboard and it's hard to type. Here's an integral, so we can put some maths in. Int a up to b fx, the x equals 10, for example, right? And so you can see that I can, through using Markdown, I can not just write code in my Jupyter Notebook, but I can document it as well. So we can talk about what we're doing and why we're doing it and how we're doing it, and then we can replicate it in the code. You can probably see already how this is going to be valuable to a research team. All right, so that's some of the facilities of using Jupyter. I'm just going to glance at the time. I got 15 minutes left. Yeah, so, you know, with Jupyter, it takes just a little while to get used to some of the quirks of it. There's an unusual editing interface called a modal interface, which means that, you know, when I'm executing code, let's shift this. I'm going to just get rid of this, so I'm going to delete it. I'll tell you how to do that in a second. All right, so look at this piece of code here. So if I click in this cell, I got a blinking cursor, and anything I type here is just going to appear. And now I'm going to hold down the Shift key and press Enter to run that. I mean, I could use Run, but usually I just hold down the Shift key and Enter. Anyway, you can see that I've got this green border around the cell and a blinking cursor, but if I click here, I get a gray border and blue here, and there's no blinking cursor. And what that means is that I'm in command mode, and whatever I type is interpreted not as something to put in the cell, but rather as a command. And one command that I might issue is DD, and that means delete. And that's going to kill this, and it's going to kill this guy as well. All right. So if I didn't realize that, I might just start typing some what I think is Python code, but I'm actually issuing commands that delete cells and so on. So you need to just become a little bit familiar with those two different, just be aware of which mode you're in. And you can tell, like I said, by looking at the cell. And you can swap like this, or there are keyboard shortcuts for swapping. So you just want to know which mode you're in. All right. Okay, and then we can go back to writing Python code. All right, so that's a way of writing code. And sometimes we're going to want to execute our own code, and sometimes I'm going to see code out there on the internet that I want to execute. And what I could do is I could just cut and paste it. I could say, yeah, all right, so here's a lecture, and I see some code somewhere down here. Yeah, there's a program. So I'm just going to grab this and I'm going to copy it off the internet, and I'm just going to do a paste here, Control V, and there it is. And now I'm going to execute it, and it runs and produces a figure. So if you see me executing some code from somewhere, that's one option to follow along. But I'm actually going to do something different now that we have some idea of how to use Jupyter. And we're going to work through a few code examples from the web. I'm going to do that by downloading all of these code examples at once, and I'll show you how to do that. I think we can get rid of this guy. I'm just going to close that. All right, so is there any questions at this point? All right, sweet. So let's see. So let's look at one of these lectures, and we'll just work through a couple of pieces of code, and then I think we'll be about done. And they're not very advanced, but maybe I'll try and touch on some of the advanced features as we go along. So this lecture here, so what I did, let me go a little bit more slowly. So I'm at Quanticon. And I went to lectures. And then I went to the first set of lectures, which is Python programming for economics and finance. And now I'm going to lecture number 3, which is called an introductory example. And now what I'm going to do, so there's a bunch of code here and I want to execute it, and I want to do it live. And this is just a website. I'm looking at a website, everything is static here. So I don't have any means of executing this stuff directly. But what I can do, because this is all created using Jupyter, is I can click on Download Notebook. So I don't know if you saw, I went to the top right there where it says Download Notebook, and I clicked on it, and I got a notebook, and I know where that is. It's in my Downloads folder. So I'm going to go and find that. So I come back to Jupyter. So this is now back in the Jupyter dashboard, which is what you get after you start the Jupyter Notebooks program. So I'm going to go to Upload, and I'm going to try and find that guy. Yeah, Python by example, this one here. And I click on that, and then I'm going to upload it, which brings it into the present working directory, and now I can click on it. And now I have the lecture here. So you can see that what I'm looking at here through Jupyter Notebooks is a version of the lecture that I was just looking at online. But this is static, right? This is just, I'm just looking at this on a website through a browser, and it's all static. But I've downloaded it and brought it into my local version of Jupyter Notebooks as a live executable version. And let's execute some codes. I'm going to get rid of this stuff. I'm just going to delete that. I don't want it. I don't really want that. I'm going to get rid of that. I'm going to get rid of that. And I'm going to get rid of that. And I'm going to execute this little piece of code here. So let me tell you just a little bit about what's happening here. So again, at the start of the program, the aim of the program is to generate some random numbers and plot them. And the random numbers in question are standard normals. So I'm going to get Python to give me 100 independent draws from the standard normal distribution, and then I'm going to plot them as a time series. And that's exactly what you see here. And you can see that the program is going to start off with imports, like I said. And we want to do anything interesting, we need to import stuff. And so we're going to be importing numpy, and I'm going to give it a shorter name. I'm going to call it NP. Import numpy as NP, that's standard convention. And then the plotting library, Matlab, I'm importing that guy, and I'm giving it a shorter name. And then I can actually start the program. And so the program says, give me 100 draws from the standard normal distribution and plot them and show me the plot. And that's what we get. And now we can start to play around with this. And, if we say that we actually would really prefer that this is a red line, we can do that. If we want a little bit of transparency, maybe we want this a little bit lighter with a line width of 2, right, and so on and so forth. All right, so let's have a little think about how this is working. And I don't have a heap of time, but I just want to, so maybe I'll just say a couple things. One of the things about Python is that when I do this import, so that I'm typing B here for below. I'm in command mode and I type B, and that opens up a cell that I can play around with. Right, so I've said import numpy as NP. And so that gives me access to the numpy library. And one thing that numpy gives me is square root. So np.square root of 4 is equal to 2. So Python itself doesn't even have a square root function. That's not part of Python. So if I want to take square root of a number, I've got to use a library. And you'll notice here that when I called on the square root function, I had to put np dot at the start of it. And you might think, so there's this library numpy and it's got this square root functionality in it. And so if I say import numpy, can I just directly use the square root function? What happens if I just type square root? Right? And now Python's going to yell at me and say, look, this square root function is not defined. So it can't see it. And technically what that means is it can't see it in the top level namespace. And what that's saying to you is when you import this functionality, that functionality is kept separate from all your other variables by default, so that in order to access it, I need to say np dot. Or if it's PyTorch, I have to say PyTorch dot and then some functionality from PyTorch. And that's one of the many smart things that Python does, is that it has this idea of namespaces and it uses them to keep our variables separate. And if we don't do things like that, like a lot of some of the other scientific computing environments don't do things like that, then you might find that you've already declared some variable and then you import a library and that library happens to use the same name and it overwrites what you've been using. And that is a source of bugs that can be super hard to find and very frustrating. So Python's thought about that and used this idea of namespaces. So that's part of the Python philosophy. And if you want to know more about the Python philosophy, about how the language was designed and why things are done the way they are, you can type import this, which is a little poem about Python called the Zen of Python. And it, I guess it was written kind of like a joke, but it captures a lot of the ideas of the design philosophy of Python rather nicely. And if you find yourself nodding your head as you read along with this Zen of Python, then you're probably going to find that it's a good programming language for you. The one right down the bottom is what we were just talking about with namespaces, which is the way that Python organizes variable names and stops them clashing. And the guy says, namespaces are one honking great idea. Let's do more of those. So he's a fan of namespaces. And I fully concur with that design philosophy. All right, I'm getting close to the end of time. So are there any questions that people have at this point?
There are two questions coming through from the chat.
Yep.
The first is, what is the best way to start learning Python and other computer languages such as Matlab?
Yeah, all right. So number one, don't learn Matlab, learn Python. No, it depends how much sway you have in the research group that you're working in. And a lot of your professors will still be using Matlab. If you go to something like Stack Overflow and then they have a measure of trends and popularity, I was just doing this today for another reason, and you look at something like Matlab versus PyTorch. So Matlab is an entire scientific computing environment, and if you look at the popularity of it, it peaked, I don't know, like 8 years ago and is heading down. And even PyTorch alone, according to this one measure, which is, it's a fairly random measure. It's not the be all and end all. That individual Python library for one specific task, deep learning, is already generating more attention than Matlab. But again, like the measures are pretty arbitrary, but I think the trend is important. So if you can avoid working with Matlab and you can use Python instead, then do that. Okay, and then in terms of how you learn Matlab, beyond that, I have to leave that to someone else to speak to. How you can learn Python. So I've just shown you some resources that are at quanticon.org, and I think they're, I'm biased, but I guess I think they're a nice place to start. They assume that you're kind of comfortable with computers and maybe you want to look at just Google for whatever is the latest Python tutorial that's on YouTube, or people are different and they're going to want different things, and just Google around until you find a tutorial that's good for you. That'll get you started, and what I've just told you will get you started. And then in terms of actually learning the language, inevitably the only way to do it is to find a piece of research that's interesting to you, and use Python to solve some important questions as part of that research agenda. And you will find, compared to arbitrary tutorials, once you do something you're really interested in and you use Python to solve it, everything that you learn will stick in your head, and you'll start to be able to say that you're a good Python programmer.
Thank you, John. And the next question builds on that a little bit. Are there any applications for which Matlab would be preferred over using Python? The idea I'm getting at from your introduction and from my own experience is that the value of Python comes from its flexibility and multitudes of libraries. Would learning Matlab purely be for legacy support, or am I being ignorant of its modern capabilities? That's for our audience.
Yeah, look, it's a good question, and I've kind of spoken to some of it. I think, Matlab, they're serious people, they're a smart company, they're smart people who designed it. A lot of the good things that are in Python have been selectively pinched from Matlab. And I would also say that Matlab, being a specialist, a scientific computing specialist, the fact that Python's really flexible and can do many things means that when you apply it to one particular area, you've got to do this import numpy as np and then np.square root. In Matlab, you definitely don't have to do that. You just say square root. Of course, it's in Matlab because Matlab is all about scientific computing. So it's not that there's no reasons to use Matlab. I think there are still compelling reasons, particularly if there's some particular library in Matlab. Maybe it's a specific signal extraction, something that MATLAB's done really well, and it just, for whatever reason, hasn't really caught on in Python. There may be some niche things like that would make you want to use Matlab. And then again, there's the issue of you're going to be working with professors, and the older the professor, the more likely they are to demand that you use Matlab. So it depends how much bargaining power you have, whether you end up being forced into that environment. But if you have a say in the matter, I would say the direction that everything is heading is really clear. So learn Python, not Matlab.
Wonderful, John. Thank you so much. And on that note, I'd like to thank you very much for delivering this workshop today, and to our audience members for attending. The video recording of this workshop will be made available post-conference, so attendees are able to refer back to it, and others who weren't able to join us live today can also access it. So thank you very much, and that brings this workshop to a close.
Thanks, guys. Thanks for listening. And like I said, shoot me an email if you have burning questions about Python or scientific computing and research. Thanks again.